I'm not going to sugarcoat this. The Amazon rainforest, which contains 10% of the world's species, is turning into a grassland. This is because the rainforest needs its own rain to keep it a forest. But as the earth warms, the rainforest increasingly becomes dry grass. We call this irreversible, vicious cycle a tipping point, and the Amazon is just the tip of these tipping points. We're going to look at 5 of them today, and the worst one, the collapse of the Greenland and West Antarctic ice sheets, is going to cause 10 meters of sea level rise, and we may have just triggered it. So wait, what is happening to the Amazon? It's going to be the Amazon grasslands in the future? The Jungle Book is becoming the Lion King? And yeah, the issue is that a wet rainforest produces its own rain and so keeps it being a wet rainforest, while a dry grassland doesn't have its own rain and so produces more dry grassland. That's the vicious cycle. So when is this going to happen? Well, there are actually 2 separate models. One of them is just based on climate risk. And that one says at 3 to 5 degrees C, it'll happen, which is a long time in the future. But if you take into account climate and ecological risks, then that would happen at 1 to 2 degrees C and at 20 to 25% deforestation. And the issue is that today we're already at 1.2 degrees C and 17% deforestation. So the Amazon is very, very close to hitting a tipping point. But the Amazon isn't the only tipping point. Here's a graph of the temperature difference since pre-industrial times. And you can tell we're already at 1.2, 1.5 degrees C. And here's an excellent graph of all the other tipping points. You can see that, like the East Antarctic ice sheet, that are unlikely to happen until the future, but there's a bunch that are currently in the danger zone up here that we're already starting to hit. So we already talked about the Amazon rainforest dieback, but we're not just losing land biodiversity, we're also losing marine biodiversity. Coral reefs hold 25% of all marine biodiversity, and they're done. So coral reefs are in 3 places. They are in Caribbean, they are in Indonesia, and they are also in the Great Barrier Reef down here in Australia. And unfortunately, we've already lost 50% of coral. So in 1998, we lost 8% of global coral. In 2010, we lost 80% of coral in Indonesia. In 2016, we lost 30% of coral in the Great Barrier Reef. And then in the last 2 years, we've had this global mass bleaching event. And you can see here, this is at the start of 2024, and it's already getting hotter and hotter. So the coral reef is turning into a graveyard. And the vicious cycle here is that a healthy reef is a home for a healthy reef. But then once you turn into a dying reef, everything goes away. So it turns into a ghost town. We've already lost about 60% of the population of animals in the world. And once the Amazon rainforest and reefs fully die out, we're going to lose even more. You know, I've never been to the Amazon or to these coral reefs, and I probably never will, but your kids are definitely never going to see them. But the other thing your kids are never going to see are mountain glaciers. And the issue here is that bright ice reflects the sunlight, and so it stays icy, while once it starts to melt, it becomes dark and then absorbs more energy, melting even faster. You know, we've already lost about 20% of the mountain glaciers, and we're going to lose probably 50% total by 2100. Now here's a graph showing the glaciers around the world and then how much ice loss they're going to have relative to 2015. So we already lost 20%. And so this is saying overall, based on these 1.5 to 4 degrees C markers, how much are we going to lose? And so we're probably going to lose, again, another roughly 50%, by 2100. So this number here is the contribution to sea level rise in millimeters. It's about 100 millimeters of sea level rise, which is not that much in the end. The oceans are big while the mountain glaciers are small. The biggest issue is right here. You can see that these glaciers provide water for 1 billion people. When this yearly source of water goes away, that's going to cause tons of climate refugees. Okay, so that's mountain glaciers, but mountain glaciers aren't the only place where the ice is melting. It's melting at the poles as well. And so we showed how when ice melts, it can affect sea level rise. It can also affect fresh water access, but importantly, it can also affect the currents of the ocean. And one of the main currents is called the Atlantic Meridional Overturning Circulation, or AMOC. And the way that AMOC works is that you have this hot and fresh water near the equator. That's pretty light. The water's really light. As it goes further north, it's evaporating, and so it's getting saltier and saltier, which makes it denser. And once it gets up north, then it gets colder, which means its molecules get smaller, so it gets even denser. And then up north, that salty, cold, dense water, it plunges down into the ocean and starts this, conveyor belt. And the reason why it's slowing down is because there are these two big engines for the conveyor belt, number 1 and number 2, and they're both having issues. So the first issue is called Labrador Sea Current Collapse. And the issue is that the Labrador Sea currently acts as one of these places where the cold, salty water plunges down into the ocean, like 2 kilometers, which is amazing. The problem is that Greenland is melting, and as Greenland melts, it produces more fresh water here, which means it's less salty, and so it's also less cold, and so it plunges down less. So it slows down the conveyor belt. But the issue is that all of the ice up here in Greenland, but also in the Barents Sea, that it is melting. It's actually melting at 7 times the rate. They call it Atlantification, where the Barents Sea is becoming the Atlantic Ocean. And because it's melting, then again, it makes more fresh water over here, which makes the plunging less intense, slowing down all of the conveyor belt. And so this conveyor belt, AMOC, has already slowed by 15%, and it's probably going to slow 33% at least by the end of the century. So here's a beautiful chart of these 2 gyres, the Labrador Sea Gyre and then the Norwegian Sea Gyre, in the role that they play as engines in AMOC. And the reason why we know that AMOC has been slowing down is because of this cold blue spot. The rest of the world is warming, but this little spot is getting colder. Why is that? Well, it's because the warm water that's usually coming from the tropics, from the equator up here, is not moving up there anymore. And so the water is staying cold instead of getting warm. This is like a canary in the coal mine for the AMOC slowing down. But who cares if AMOC slows down? It's just some big sea current, right? Well, the AMOC touches everything. And so if you change this, then the whole system goes haywire. But there are 2 specific issues in America and in Europe. So in America, when you have this water not flowing north as much, when the Gulf Stream and AMOC stop flowing north, that then leaves the water here. We're gonna get maybe a meter of sea level rise on the east coast of the US as a result of this. Now, the other issue is for Europe. Europe gets a lot colder when the AMOC collapses. So this is an image of if there's no AMOC collapse, well, then the warm water keeps on going north and it's all good. If there's a little bit of a collapse, then Europe gets a little bit colder. But if there's a full collapse, then Europe drops into this pretty intense ice age and it becomes more like northern Canada or Russia instead of those balmy London summers. Okay, so that covers the Labrador Sea Current collapse, the Barents Sea ice loss, which when those 2 happen, it makes it more likely that the Atlantic current is going to collapse. And as you can tell here, all of these are going to happen at 1.5 to 2 degrees C, while AMOC collapse in theory happens at more, and that's full collapse at that amount, but we're definitely going to get a lot of a slowing down because of these other effects. Okay, well, what about this one? Northern permafrost abrupt thaw? It doesn't matter that much. It just means all of this permafrost up north is going to get released into the sky, and it'll add, 0.1 to 0.2 degrees C, and we'll deal with that when we get there. But these 2 at the top are super, super important. The Greenland ice sheet collapse and the West Antarctic ice sheet collapse. So I flew over Greenland recently, and unfortunately, it's melting. It looked still pretty frozen to me. I don't really believe in climate change, but it's melting. So Greenland and Antarctica are melting. And the issue is that in Greenland, bright, tall ice is cold, and so it reflects more light, versus when it starts to melt, it lowers the elevation, it gets warmer, it also gets darker, which absorbs more light. So even if you go a little bit above a certain temperature amount, then the whole thing begins to melt, and then it melts increasingly quickly. And Antarctica is similar, but a little bit different. So as a reminder, Antarctica is massive. It's the size of the United States and Canada combined. And there's the East Antarctic ice sheet and then the West Antarctic ice sheet. The West Antarctic ice sheet is the one that we think is going to collapse sooner. And the reason is because it's in this big bowl. And so you have the ice in this big bowl. And the problem is that once you get a little bit of melting on the edge here, of the edge of the bowl, then the ice can start to come in and go underneath the water and then melt the rest of the bowl. So you can see that here, the previous ice shelf was maybe out here, and then the ice front goes back and back. And as that thins, then instead of being what's called the grounding line, instead of being connected to the ground here, where the water can't get in. Instead, the water gets in, you get more melting in the bowl, and the whole thing melts quicker. So I have some bad news and some good news about Greenland and West Antarctica. The bad news is that we've triggered these cascades. We're essentially already in a place where they're going to melt. The good news is that it's going to happen over 5,000 years. So it's a long time. The bad news is that it's going to raise sea levels by 10 meters. So we might get 1 meter of sea level rise by the end of the century or next century. But then over the 5,000 years, we're going to get an additional 10 meters. You know, that's a few story tall building, and that ruins everything. So to understand what 10 meters of sea level rise means, let's look at this awesome map that'll show us what's going to happen. So here's us at 0 degrees of rise. Everything looks great. You know, by the end of this century, maybe next century, we'll be at, 0.5 meters, getting up to 1 meter of sea level rise. Not great. A little bit of red starts to be on the map. But then let's see what happens when we go to 10, which again, I think is likely to happen over the next 5,000 years. So you can zoom in, you can think about what's happening to America, what's happening to Europe, and then what's happening to Asia. Well, in America, you can see here, Louisiana is mostly done for. It doesn't really exist anymore. New Orleans is totally underwater, obviously. Florida mostly doesn't exist anymore, especially Miami, Jacksonville, Tampa, all the cities. And then the eastern seaboard is also totally done for. This includes Philadelphia, which will be underwater. New York will be underwater. Boston will be underwater. And Washington, D.C. Let's see, how's the White House doing? How's the White House doing? Okay, maybe the White House will be just, half of the White House will be fine, but the other half won't. 10 meters of sea level rise is a crazy amount. You can look here at New York. It's going to completely change what New York looks like. Here's Manhattan. Here's the Upper West Side. Central Park. New York might turn into essentially just Central Park, while the rest of it, New York, Brooklyn, etc., turns into a floodplain. What about Europe, though? All things considered, Europe fares better. I mean, all of the Netherlands goes away, obviously. It's kind of a delta port town. You have, Venice goes away. It's already underwater, And then, but the crazy stuff is stuff like London. London, the river fills up. And then you have all of Westminster Abbey and London Bridge and all of that. The British Museum is barely sticking alive, but the London, maybe a third or half it becomes underwater. I think the worst though has got to be Asia, because the problem with Asia is that everything is at these deltas. So Bangladesh, it's kind of like the Louisiana of Asia. Bangladesh goes away, 300 million people. All of these big parts of Southeast Asia, Yangon, Bangkok, Ho Chi Minh City, Hanoi, those all go away. Lots of just Indonesia as a whole, Jakarta and other big parts of Indonesia, which has, 300 million people, that becomes overwhelmed by water. And then much of China as well. Shenzhen, Guangzhou gets totally overwhelmed. Shanghai, all the way up to Nanjing, up the river here gets, messed up. And then Tianjin, you don't get all the way to Beijing, but again, a huge megalopolis of cities here becomes underwater. Okay, so that's what's going to happen when the Greenland ice sheet collapses and when the West Antarctic ice sheet collapses. And remember, those are essentially already happening. This graph shows 1.1 degrees C of global warming is here, but we're really at 1.3, 1.4. We expect to be at 2 by 2050, and then by 2100, 2.5. And so all of these things are likely to occur. Lots of them are likely to happen quickly, like the Amazon rainforest and the tropical coral reefs, while some of them happen more slowly over thousands of years, like these massive ice sheet collapses. So yeah, to conclude, the geospheres and the biospheres are collapsing. It's going to cause a lot of societal collapse as well, refugees and deaths. And I think I could, if I want to, do what these other climate videos do, like the Al Gores of the world, where they say, but don't worry, there's still time to stop it. There's not. I mean, it's really hard to steer the big ship. And it's not inevitable, but the incentives kind of bake this all in. We're going to get to 2.5 degrees C. All of these tipping points are going to get hit. And it's going to create a totally different Earth for the next 100 years and also the next few thousand years. So yeah, the Amazon and all of these coral reefs, they're done for. And that contains lots of the biodiversity in the world. And meanwhile, the mountain glaciers are all melting in Alaska and in places like the Himalayas. And that's going to leave, billions of people without water. Meanwhile, our poles is also melting, which then makes too much fresh water in the oceans, which means that these currents become a lot slower, especially affects Europe, which is going to turn into a little ice age. And then of course, the ice melting here at the poles adds a ton to sea level rise, completely changing our climactic niche that we've existed in forever. And the crazy thing is, in none of this did I actually talk about heat death. But that's of course happening with hot bulb temperatures in some of the places in the world that have the most people, and we're going to get a lot of excess deaths from that as well. So I'm not really trying to accept defeat here, but I am trying to accept reality. And then as we accept that reality, we can mitigate and adapt to it. Thanks as always for listening. If you have questions or thoughts, please let me know in the comments. And again, this is part of the series on how everything evolved, where we look at how everything came to be, but then also look at the situation today. For example, we created this whole library of atoms, all the atoms of Earth. And then we also, after that, created this library of genes. We created the biospheres in addition to the geospheres. And then we're now creating this anthroposphere of humans in the Anthropocene. And fundamentally, what climate change is it is the library of ideas, or the anthroposphere. It's us putting selection pressure onto the geospheres and onto the biosphere. Thank you as always for watching, and thank you to Roots donors for supporting this channel. If you want to understand more about the past and how we got here, check out the previous videos here. And if you want to understand the future and where we're going, feel free to subscribe here. Hope to see you then. Bye.